Hello, we are discussing about GATE 2007 ECE paper, and the topic we are discussing is electron devices. This is second 1-mark question, came in 2007. In a P plus N junction under reverse bias, the magnitude of electric field is maximum at A, the edge of the depletion region on P side, B, the edge of depletion region on N side, C, the P plus N junction, D, the center of the depletion region on N side. In a P plus N junction diode under reverse bias, the magnitude of electric field is maximum at the P plus N junction, that is at the center of depletion region, exactly at the junction. This is the right answer. Answer is C. We will see the details. This is a diagram which represents a PN junction under open circuit. So whenever a P and N type are going to be added, there will be a depletion region called, that is also called as transition region as well as space charge region. This portion is going to be treated as space charge region or depletion region or transition region. Before that one it is P type, and after this one it is N type. And P and N type are going to be extrinsic semiconductors. They are always neutral. So these portions are indicated with neutral region. N side is also neutral region and P side is also neutral region. Over this place depletion region is going to be forming, and depletion region there exist charges, positive ions on N side and negative ions on the P side near the junction. So there will be ions are going to be immobile in nature, so they stay like that only. Whenever they are going to be immobile, at that time there will be always electric field induced between positive ions to negative ions. So always the electric field induced is in this direction from N to P, and because of that electric field there will be some small built-in potential will be produced, and that is what we call it as built-in potential or contact potential. And for this one, if you are going with this charge, how the charge is going to be distributed, that was indicated with rho v. Rho v implies nothing but volume charge density, and since it is positive ions, so here rho v is positive and it is negative ions, this is negative side. Rho v is for N side it is positive, for P side it is negative. Volume charge density is nothing but how the ions in the depletion region are distributed, that is what is it indicating. This is example for the abrupt PN junction. And how do we locate electric field? How do we draw electric field for the given charge distribution? From Poisson's equation. Poisson's equation is nothing but dou square V by dou x square is equal to minus rho V by epsilon, where rho V is nothing but volume charge density, that is what given thing. And electric field, we know the equation for electric field, that is minus dV by dx. From this equation, if you want to write minus dV by dx, integrate this equation 1. So minus dV by dx will become integral of rho V by epsilon. That implies nothing but electric field is nothing but integration of volume charge density. Electric field is proportional to integration of volume charge density. So that if we integrate this volume charge density, then you are going to be getting this electric field. Very simple how to draw this one. Look at this one. During P side, the charge is going to be, volume charge is negative, and this is going to be constant. The value for this one is nothing but Q into Na. Volume charge on P side is Q times of Na. That is constant. If you take integration of constant, it will become constant multiplied by x. So that will become a straight line with some slope. Since the value is going to be negative, since the constant value is negative, here we will get negative slope. So with the help of negative slope, we have to draw a line till the end of negative charge, that is nothing but at the junction. Now this is at the junction electric field. From here positive charge is going to be starting. Positive charge and positive volume charge is nothing but Q times of Na. Q times of Na is positive, so if you take integration of that one, Q times of Na into x you will get. So as it is positive. Now the straight line is positive slope, so that it is starting from this point and it is increasing with positive slope, and it terminates at this point where the charge is 0, because we are entering into N region where the charge is 0, so that electric field is also 0. Electric field is 0 in P side, electric field is 0 in N side, because they are going to be neutral regions, and electric field is starting from this end to this end, that is nothing but left end to the right end of depletion region, and it is going to be the maximum of magnitude at the junction. This is what the point, very important. This is at the junction electric field is going to be constant maximum, and after that one, if you are moving towards N side, at that time it again reduces towards 0. So electric field always will be maximum at the junction, whether it is open circuit, whether it is forward bias, or whether it is reverse bias, because electric field is only depends on charge density. That charge density is going to be same. Same charge density or same charge you are going to get in P side as well as N side, so that you are going to be getting whether the charge maybe looks like different if you are going with P plus N or P N plus 1, but actually the total charge is going to be same, so the total electric field on both sides is going to be same. That's why then only you will get the 0 electric field over this point, because negative is going to be added with positive, so that you are going to be getting 0 over here. Electric field is maximum at this point, remember that one. So magnitude of electric field at the junction, which is maximum value, that can be written as QNA into Wn by epsilon, QNA into Wp by epsilon. Till now we have seen that one. QND, QNA is nothing but rho v by epsilon into x. That x implies nothing but Wn, and x can be written as Wp with respect to P side, with respect to N side. So maximum electric field is always at the junction, whether it is forward bias or reverse bias or open circuit, whether it is a P plus N junction, Pn plus junction, or simple Pn junction. So the maximum electric field can be calculated by using this equation. The correct answer for the given question is C, at the junction, that is P plus N junction. Thank you.